Dr. Vinesh, thank you so much for accepting our invitation
It's
and
my
for
pleasure.
agreeing to this interview. So I would like to start from where it all began. Was becoming a scientist your childhood dream, or was it something that you sort of wanted to do once you grew older?
Yeah, I mean, every child, or no, I don't know whether every child, but most childs, I think, at a very young age, you think that being a scientist is the greatest achievement. So I also had that dream of becoming a scientist, but I never thought at that point that I would become this kind of scientist. I didn't know what a scientific process was at that point, but then I thought that I want to become a scientist. But after, this was very young, but during my 10th grade and so on, that part was never there. So we just want to become an engineer or a doctor, that sort of thing. And then I knew that I can never be a good doctor because I was just afraid of blood. So then engineering was the other option. Again, I didn't have any background in engineering. But I went for chemistry. Again, getting into chemistry was very difficult. And I mean, difficult in the sense that it was accidental. I had a love for physics, but then out of some luck, I reached chemistry. And then I continued to do my BSc, and even then at that time I never thought of getting into science. I want to be a bank manager or something like that. Good in maths, but I was never good in. I thought I can never become a scientist at that point. Later, being in IIT, when I got into IIT at MSc, then I started having this idea of, okay, we'll have to do something with it. That's the reason. That's when I decided, okay, this might be a career. And I then joined with my first, where I first looked at NMR, or one of my professor N. Chandra, he just moved in from CLRI to IIT Madras, and he was teaching us a course. He was a great teacher. He's a great teacher. And he was one who introduced me to NMR, and I just started loving the whole concept of spins and what we can do with spins. That's where I started, okay, I want to do science in this.
So that is how you ended up in IISER.
But I never thought I'll become a scientist in that point. I mean, where I can become, or where I'll be teaching, or I'll be doing research. That even then at that time I wasn't so sure. But circumstances made me come here, so I don't regret it. I'm happy about it. Well, would I be doing better? I don't know. I have no idea. But it's what fate has led me to.
But no regrets.
No regrets.
Yeah. Dr. Vinesh, right now you're at IISER Trivandrum, and you are an associate professor from School of Chemistry. What is your current area of research?
The area of research is basically I'm working with either disease-causing amyloids or functional amyloids, and I'm looking at the structure of it, structure and how that affects the function. Basically, being a disease or being a functional part. The way I do it is through NMR. And we can go and see what is NMR room is and what is an NMR is all about.
Sure, sir. Yeah. So currently you're an associate professor from the Indian Institute of Science Education and Research, Thiruvananthapuram.
Yeah.
So IISERs are considered to be these premium institutes in the country where for research technically. So what makes IISER so special, and what are the opportunities students get that they don't from any other institutes?
IISERs, it was started with the aim of having to impart scientific research-oriented teaching to young kids from standard +2 onwards, right? So that is, and still after 10, 12 years, I think still in the country, these are the only institute that does that. So those who are interested in science in our time, we had to join a local college. We never see instruments. We never see researchers. We were even afraid to join research. In my first answer, I said I was not even interested in research up to MSc. Right? So here is an opportunity when people come in after their +2, very enthusiastic students who are got after +2. They have been taught by faculties who is doing research for major part of their life and who is actually working in the lab even now. So the students have the opportunity to join these labs from the second year onwards, mostly, but you can also join for theoretical sciences even from the first years. And they get a feel for the research.
Correct.
And that, I guess, is a very good opportunity to attract more students into science than just going through your local standard BSc, MSc level, because the facilities in these colleges are not great, honestly. So we have a very well-funded, at least initially well-funded institutes where there's a lot of scientific instruments, a lot of good faculties, a lot of good researchers being there, and that will definitely help them to prosper later in their life.
Correct. So, sir, IISERs pride themselves to be the hubs of interdisciplinary research, and your work sort of works at the intersection of chemistry and biology. So, could you tell us a bit more about how you ended up choosing this field and what really excites you with respect to this work?
When I started with my masters, as I told you, I never had a great idea what I wanted to do at that time. Then a professor from CLRI, Professor Chandra came to IIT, and he started teaching NMR. And NMR was something, and he sent a project title to everyone in the class, which I could not make head and tail of. What I understood was it is about spins, and I was really interested. Something quantum mechanical entity, how one can manipulate it to your bidding to give answers on the chemical or biological structure.
Nice.
So the whole thing was a fascination for me. And I didn't understand at that time. I didn't understand a thing of what was said in that project. So I went, read a lot, and with Professor Chandrama's help, I studied the whole thing. And then I got interested that if I wanted to do research, I'm going to do it in NMR. So
and that is how you landed up.
I landed up there. But nice. Then he was not doing any bio molecules. But when I went for PhD, the whole thing was bio. And there I met a number of postdocs, especially Pierre Mondeville. He's a postdoc from France, and he was talking about biological system as if something living, something fascinating. Before that, I had all this idea biology is just mugging up, there's no logic to it and things like that. But Pierre Mondeville was speaking, the passion that he had for that subject and the way he thinks in a very logical way, things will bind here, that something is going to happen on the downstream, things like that. The terminology started ringing. I used to do NMR for him, and he used to just keep talking about this system. And I was so fascinated by the whole the biology itself, and started to like the subject and read about it. And that's why when I came back to India, I decided that I will not do any more methodology, or at least I will reduce the methodology and then start working on important biological problems, or things that I can handle. And I didn't have a prior experience cloning, expression of proteins and things like that. Everything started after coming here. I was more of a physical, biophysics guy. Chemistry was off, but biophysics, I know a lot of physics, but also some biology.
And you were good at math also.
But I had a background in chemistry. So whole thing was like a different experience. So now I'm in chemistry, which helps me because every time I can think of it in a chemical sense.
Sure.
Because my training is in chemistry, I always rely on the chemistry part to survive. But biology part and physics part is where I marry, get married.
Yeah. So this is the NMR room?
Yes, this is our NMR. This is the 500 NMR that we recently installed. This is from DST FIST sponsored. It's funded by DST FIST. This is our workhorse 700 NMR, from our group.
Okay.
Obviously all three of these are central instrumentation facility. This one, and out there you have the 500 megahertz. The 700 is where one uses for proteins. Okay, so it's at a higher magnetic field compared to the 500 megahertz. But this is for solid state NMR. You can do solid state. This is dedicated solid state NMR. So what we are doing right now is filling liquid nitrogen into the stiva. It has to be kept at so liquid nitrogen is 77 Kelvin. So the magnet is in liquid helium temperature, and outside it is covered in a curtain of liquid nitrogen. So every week we have to fill liquid nitrogen because that gets evaporated because that is closer to the outside, right? And so we have to fill. So this is basically the inlet goes here, outlet comes here. When it's filled, it will start sputtering. You will hear that sputtering. That's what is happening right now.
So we were just talking about your instruments, NMRs. Could you talk us more about how you're using these instruments to answer questions at your lab and their applications, if any, in the industry?
Yeah, it's a little complicated question. It's very in simple ways. I have to explain it in a simple way. Right? So we look at interesting parts of the protein, not the entire protein sometimes, but we look at interesting part of the protein which are involved mainly, in our cases, mainly in the aggregation process. I mentioned like we are interested in the like the amyloids forming protein, amyloid forming for proteins, which can be disease causing. The other can be functional also. There are functional amyloids as well. So in either cases, we are looking at that very part of the protein, the core part of the protein, which is involved in the aggregation. And we're trying to use both solution and solid state NMR to understand what is the initial steps of this aggregation process. So that is the basic idea. Now, how do we do that? Is through NMR, definitely. And first we assign the protein. Assign meaning the protein will have certain NMR signature signals. We identify what these signals originate from, where these signals originate from. So once that identification happens, we call them assignment. So once that assignment happens, that means every residue in your protein can be assigned to a peak, to a particular peak in your spectra. Then we can see the fate of this peak as the protein aggregates. So what happens to this peak? This peak is unique to that particular residue, amino acid. Alright. So if the environment, chemical environment around it has changed during the aggregation process, that will get reflected in the position of this peak. This round stuff that you see in the spectrum. And that will help us identify what are the initial stages of the aggregation process. So this is where we are trying to do. Also, we are interested in the dynamics. What kind of dynamics play? Not only NMR, we do other biophysical methods too to understand the dynamics of the protein. We do molecular dynamics simulations. We also do NMR experiments where we probe the dynamics of the protein, how proteins starts aggregating, what kind of motions the protein have. All this, these are all what we are trying to decipher or find out the protein. So I work on tau proteins, tau protein which is involved in Alzheimer's and other taupathies. So the aggregation, abnormal aggregation of this tau protein is involved in all these neurodegenerative diseases. So we are interested in what are the initial steps of this aggregation process. Therefore, we work on different constructs of tau and try to understand what is the initial step. Then we work on a functional amyloid, CPEB3, which is cytoplasmic polyadenylation end-binding protein. That protein is an RNA binding protein, and that is involved in long-term memory in mammals. So the aggregation of that protein, CPEB3, helps in polyadenylation. Okay. So it adenylates, and it helps to create. I mean, the downstream, it creates a large protein expression at the synapses. So that is like a trigger. The aggregation, there is some impulse which tells you it to aggregate, and that is a trigger for the cell to form connection strong. I mean, to maintain the connection very strong, not to form the connection, but maintain the connection. So if maintaining the connection is important for long-term memory. So there is a lot of proteins that is required for the maintenance of the memory, and the aggregation of this protein helps in the expression of these proteins. That is required for the maintenance. So we work on such proteins. I mean, I don't think many people actually in India work on such in CPB3. I don't know. There may be one or two groups. Yeah, so in many of this work, I collaborate with biology people. I mean, I collaborate with Professor Murthy to do some cell biology work. I collaborate with Professor Tapas in certain proteins, EB1 for example. I work with him. There we are looking at the dynamics of the EB1 protein. So there is some level of collaborations, but this is all initiated from my side or on the other EB1 case, our side. So, yeah.
So doing PhD itself is very taxing, and in a situation like a pandemic when people are not allowed to communicate the way they used to, there is going to be some sort of impact on our mental health as well. And mental health makes a lot of difference with respect to a researcher's life. So how do you keep a very healthy environment in your lab? How do you interact with your students about things that are not research?
I'm a person who don't impose being a boss. I mean, I would like to get things done, but I'm not like I'm never angry with my students. I never talk to them in an impolite way. If they are struggling, I give them the time, space to understand and move forward, and I will do that. So they have complete freedom with me in saying what they are saying, and I have no problem with that. I haven't seen so much of conflict within my group. They seems to be all gelling well and then working together. I do not know exactly if they are doing it, but I'm pretty sure they're not. I mean, they are not. They do not have conflict among themselves. They are in different projects. Each of them understands the complexity of their projects, and some might get some results earlier than the others. But finally, it's the amount of time, it's the amount of effort that you're going to put in that project. If something is not working, I change the project. But I'll see to some extent to still go there if I'm sure that this is not going to happen, also depending, I mean, different students have different abilities.
Correct.
And depending on their ability, I give them the projects, trying to make them understand that this is the project about. Why don't you? And most of the students I'm talking about the PhD students, I'm not talking about the MSc students, I'm a BSMS. Even a BSMS obviously has like 4 years to know me, and I teach them, I teach them from the first year, so they know me from the first year. For the PhD students, those who have joined me are mostly the students who has already known me, what my lab does, and what is the time it takes, and what is the amount of effort they have to put in. They know about it. So most of my PhDs come from integrated PhD stream, and those from BSMS who has transferred to
a PhD program. Yeah.
So my own BSMS. So they know me pretty well before they end up, because I don't want to. I'm in chemistry, and I do a lot of biology. So there is a time gap for certain publications to be made and stuff. So so they have to know that. I don't want a new guy to come in and believe that okay, they are going to get publication just like the standard chemistry lab does. That's not happening. I mean, that's not. I would try to, but it's just not me. So I can't work on a chemistry problem just like that.
Yeah.
So my projects are more biologically oriented, and therefore it takes some time, but they understand that, I guess. But right now, for the last so many years, like when I started around 6 years, there was a lot of problems. I mean, then we didn't have instruments and stuff, and therefore I could not be more productive at that time. But right now I can, with all the instruments, I can do more projects. And able to measure more spectra, analyze, and publish. So right now I'm getting into a good level of publication.
I mean, after taking a couple of your courses and after interacting you here and there, despite of being a student in your lab, I know how jovial you are, and I know how comfortable students can be with you, despite of them working under you. So I'm pretty sure there's a
you can ask them honestly what they think about me. but I haven't been nasty. I won't be. What do you call it? Well, I don't want to use the word. But that's how I do. I may lose my temper with my seniors who are above me in pay grade, because they are the people who might know my struggle but still refuse to
support.
Not refusing, they just doesn't want to think about it. And therefore I lose my temper at some time, but that's it. But I don't have any personal enmity to anyone, because these are all part of the game. I don't know. It's if you are in any field, there is some level of politics. There's some level of enmity and healthy jealousy, being competitive. These are part of whichever field you take. You have to be just. And you have to just assume that this is going to happen. I've worked in Germany for 8 years, so I know that even there are so much of this stuff going around, and here also there are so much going around. And but take them. You take the good quality from remove the bad quality out. That's all. I just otherwise your life is will be miserable. You will think about it. Did I do bad? Did I do bad? You start to ask questions about yourself. I do that, but still I don't want to do it. I don't want to do it. Then okay, this is the best I can do. This is me. This is what I can do. I try to be my best. I do my best, and the rest is up to whatever.
So Dr. Vinesh, a lot of times what happens is a lot of BSMS students, just like me, we often end up doing PhDs because we do not know what other options are out there for for students pursuing BSMS right now. Are there any other careers people who are doing masters in research right now can pursue?
I'm not a very senior professor to give a very comprehensive answer, but there are, of course, in what I've seen from foreign universities and other places, what I see is that students, even after PhDs, they go into different areas. In terms of BSMS, when you enter BSMS, when you start the BSMS, you have to know what you want to really do. You want to do research, where you want to see after 5 years, because right now after +2 you get into a BSMS, that should not be your aim. I got into a institute, a good institute. You should not stop there. You have to know what is the next step, because that's not the end of life, right? You have to see where you end up after 5 years and then work for it. If you are going to do research, let's say I'm not going to worry after 5 years, I will do a PhD and then worry about my future, then work for it. Work for getting a PhD. Work for finding what area is interested to you. From the first year, second year on, you should do internship and other skills that might be required for your PhD in the area of research that you want to do. So find the area that you are interested in, and importantly, do internship with professors who are related, who's working for it. Now, if your interest is not doing any PhDs or anything, then you should acquire as much knowledge through your studies and have multiple
skills,
skills that you should acquire during your master's level. That will help in your career, in your application process, and also in getting to any other areas that you want to do. So you should know where you want to end up. That is the most important. You have to have an aim.
Correct.
Many cases, including me when I joined, as I mentioned, as I was saying, that you do not have an aim where you want to end up. It's very difficult to have that aim, because we are always with our parents, and always the parents who push us. Only when you get out of your parents' clutches, then you can think freely. At that point, you have to think what you want to do and if you are in IISER system, there are multiple opportunities, or you create that opportunity and find a way to get your, because there's a whole lot of stuff that one can do. If I had to go back, I would have done everything in a different way. We didn't have that like IISER or any other institutes, but then I would have done it differently. I would have done something. If I knew that I wanted to be a researcher, then I would have done it a slightly better way. But that is how you should do. There are a lot of for me personally, getting to engineering or getting to medicine, I think one should at least start after BSc. Only then they are mature enough to do this.
True, very true.
After the Indian kids are slightly less matured, because they don't. After 18, you're still with the parents, and once they come out of the parents thing, then only they realize, okay, this is my life. I have to do something with my life. Then they start thinking on their own. They're putting more effort to be responsible. That is the important part. The student has to be responsible for their life. I guess for anything, engineering or medicine, BSc should be the standard, and then they can apply. +2 is too young for them to apply.
Realize,
In other universities, it is like that. They have to do college or schooling goes up to more than 18 years. Then only they start working for their medicine or other degrees. And also the degree might not, we don't have to give them 5 years, medicine or this one. You have to give them only 3 years because they have already studied the BSc or BS part, and then they go. So I think we should get into that system. And being in an IISER system, this would help because they have a multiple good faculties teaching multiple subjects. Research is going on. They know what kind of research people are doing, and in their future life or in their when they are taking a specialization, they would know that how to relate what they have studied here to something that they may be doing at that time. So I believe that would have been the best scenario. I had a colleague who finally ended up with McKinsey. He was a very good researcher, but he uses the whole process, idea about understanding a problem, solving this problem, the communication skill, the ability to frame questions, the ability to answer questions, also to articulate answers properly, the writing up everything. All this is the basic training of any researchers. And once you have that, this is a sought after skills that any high-end management team would also be happy to have. So they can go. So some of them have gone to industries. Some of them have flourished in industries, especially outside. Of course, in India, such transfer has not been that many, but still there are people who moved out after doing PhDs and gone off.
So we are at the end of our interview. So finally, if there's one thing that you could change in the way that research is happening currently in our institute or in the country, what could that be?
I think one can have more interdisciplinary areas that should be encouraged, should be promoted, should be arranged. I mean, we have to bring the whole system has to bring to the people, so that they talk to each other. Then only I think science can improve. There's a lot that can be done from the physics point of view, the chemistry point of view, and biology point of view on their own. But then when they come together, we can produce something big. And there has to be incentive for that. And I think that needs to be encouraged. The problem is when the whole system is inertia. There is a lot of inertia that you are a physicist, they think they are pure. Chemists think they are the purest form, and the biologists say okay, everything else is they are doing something else or something. Biology is still acceptable. They do have more people coming in, but still the other fields don't have that, and I think the other fields should also open up and bring in more people of interdisciplinary nature. I mean, the whole IISER system started in that principle, but it has to be encouraged. More people has to talk to each other, have collaborative research. Then I think we will succeed. The strength of India is in the size and the human power, and we should use that. We should have more such people, a lot of more faculties, a lot more science. Because if one cannot do, there will be multiple people coming together and making it happen.
Very true.
That should be the idea now.
Yeah, very true, sir. So that was wonderful. Again, it was a delight talking to you, Dr. Vinesh. Thank you so much for accepting our invitation and for making this happen.
Thanks for having me.
And I really hope a lot of people are going to get benefited by this.
Oh, great.
Thank you. Yeah.